you can't see the whole thing. Okay. So we've done left, right, midpoint, trapezoid, and now non-uniform partitions. So today we're going to need a calculator. Okay, so now we're getting into real integration. We're not going to do approximations anymore.
When does this lesson end, or like this unit?
Actually, hold on. Let me look.
Where's my calculator? Do you have an extra calculator?
No, not with me.
Yeah.
This goes all the way to the end of the semester.
Do you have a calculator?
In my room. Like the room I share with Tyler.
I don't remember if I took it out.
You get it to for the morning meeting.
No, I didn't.
Yeah, you did.
I was all the way in the back.
Exactly, you do it.
Oh, okay, yeah, no, we have to.
Nah, Jesse took it out. You don't think.
Okay, let's start by doing A. If you can remember in your calculator how to find the exact value of the integral from 0 to 3 of this function f of x, this parabola right here. So go ahead and do that.
Can you go give me a calculator while we're doing that?
You can get
I don't know where your classroom is.
the room that I share
Can you
with
go
Tyler.
get it?
The room that I share
Can you
with
go
Tyler.
get it?
No, you go get it.
Thank you.
Sharpen my ceiling.
Go get it. I don't want to go. Is there a class in there? Yeah,
Yeah, Tyler's
it's.
class.
It's on.
Why y'all being weird? Just go get it.
We're
Oh,
taking
Fowler's
a
like-
quiz in Fowler's class.
We are? Today?
Well, my other told me.
Oh, so we can use notes though. We can use notes.
Let's do it.
That usually means a bad thing.
No.
Just saying in college, if professors were like, yeah, it's open note, it means it's gonna suck.
Cause it's gonna be hard.
Yes. It means it's too much material for you to memorize, so you have to. Just saying, in all of my experience, that's the way it was. Maybe not always.
Is it? No, I
Okay, integral from 0 to 3 of my function f of x dx 39. Okay, just a refresher on how to do that.
Get a better translation.
I gave you all my good pieces.
Okay, using 8 rectangles of equal length and the right endpoint method, estimate the value of the same integral. Okay, but before we do that, looking at this thing from 0 to 3, is our estimate going to be an overestimate or underestimate?
What?
Is our estimate going to be an overestimate or an underestimate?
Over,
Why?
because it's increasing.
And what?
I totally guessed that.
It will be an overestimate.
And it's a right. 29.
What?
So right.
And the right endpoint method, yeah. Remember, that's enough of a justification. Okay, so let's do this where it's not so easy. All the other intervals that we've done have been to where like it's like from 0 to 3 with 3 intervals. Like the intervals are like really nice and clean. Now it's from 0 to 3 and 8 intervals, so not going to be very clean here. This is why I used f of 0 and stuff yesterday. Okay, so delta x from 3 to 0, and I want 8 intervals. So my intervals are 3/8 wide.
That's nice though.
Yes, it does. Okay, so the interval from 0 to 3 f of x dx is approximately. Okay, so think about this with me in the picture. This is 8 different rectangles that we're finding the area of, right? So length times width. So here's like the first one, 3/8. We're not gonna approximate that height. We're gonna actually use the calculator to find it. Okay, so the y value, the height of that first rectangle is right here at 3/8, because that's my delta x. So if I want the height of that thing, it's f of 3/8. Okay? If I do the second one, I go up. Now I'm at 6/8.
Bless you.
Thank you.
So the height of that rectangle would be f of 6/8. So here's you'll see that. Here's you'll see that we have. Okay, so what is the height or what is the width of each of these rectangles? 3/8, yeah. It's always my delta x. Okay, so the first height was f of 3/8, whatever that is. The height of the second one that we just did was 6/8.
That's a 9/8.
Yep, we're just gonna keep going. How many of these should we have?
I don't know.
So we need to, what, 3?
Yeah, we should end at 3, right? Because it's the right endpoint method.
So a lot.
And we're having 8 rectangles, so we should have 8
So it
function
should be
values.
24/8.
Yep, that's the last one, yeah.
Dang, that's too much. I don't even know if it's gonna
1,
fit in my
2,
paper.
3, 4, 5, 6. Yeah, so if you finish this and you don't get to 24/8, something is wrong.
You got it wrong. No, I was just saying, like, something went wrong and you added it
Oh,
wrong.
gotcha. Thought you were trying to call me out.
This is good.
I always turn the lights on.
That was sad, you know? Sorry.
We are.
Okay, so obviously, I'm not gonna do that by hand. I'm gonna look at the calculator. So I'm gonna do this the easy way. I'm gonna graph this function first, so that I can reference like f1 of 3/8 instead of plugging, like I don't wanna solve for each of those and plug it into the formula. That's ridiculous.
What if they don't give us the function? Who wrote that?
I wrote no excuses.
I put AP calculus.
In this case, they would give you the function. And if not, they would have to give you a table of values, like we did yesterday. Okay, so there's my function. So let's go back here. I'll do this on my computer actually. Alright, so f1 3/8 plus f 6/8. So yes, this is kind of tedious.
TD.
What did we say, overestimate or underestimate? Overestimate, so it should be greater than 39. The actual value that we just found. Make sure we got everything. 3/8 times f 3/8, 6/8, 9/8, 12/8, 15/8, 18, 21, and 24. Definitely an overestimate. 0
It
to 3.
shouldn't be an equal sign.
Yes, it is.
dx is
Right where
approximately.
we could put, an equal sign?
No, it's an approximate sign.
No, an
If you
equal
read
sign,
it in the notation that I just did, it needs to be
No.
approximated.
and the equal
But-
sign to that.
This, yes.
Zero. Don't ever correct me.
Wait, where'd you get the numbers from?
On the function, cause it's 3A, so we just keep adding 3 until it gets to 4, cause that's when we, that's when it gets to 3.
Okay, remember like when we started this, I said the more rectangles, the better? That's where we're getting. So in part C, let's generalize this process we just did. Using the right endpoint method and n integral, so for any number of rectangles we want, create an expression which can be used to estimate this integral. Okay, so how did we get the width of the rectangles?
Delta X.
Delta x. Okay, so let's generalize delta x for n rectangles. It's still 3 minus 0 because those are the bounds of our definite integral. But now we're not doing 8, we're just doing n. So now our width is 3 over n. Okay, where's the first height?
And 3 over n.
3 over n, yeah. When n was 8 here, the first one was 3 over 8. So whatever that first n is, okay, what's the second one?
6 over n.
6 over n. I don't know how many are in there because we're using n rectangles, but I should know where I finish. Using the right endpoint method.
So we can put dot dot dot?
Yep. From 0 to 3, where's my last endpoint gonna be?
3.
At 3, yeah. Whatever that size is, it will always be at 3 for the right endpoint method.
Can we just put 3?
Let's just put 3. That's better. So if we have an n that's really large, then our approximation will get really good. Okay, maybe you can see where we're going with this? Maybe not.
Submitting.
Okay, next page.
I feel like I'm in EQR right
It'll change it a lot in just a second.
now. Huh?
It'll change a lot. Okay, now we're gonna start using sigma notation. Tell me how to do this.
Nope. Oh my god, I hate that.
So this is the sum starting at usually 1, the sum number k, like whatever the final number is. And then some expression in there where I continuously plug in I into my function. Because this is just a sum, right, what we just did?
Yes.
Okay, so let's express this integral as a Riemann sum. Still using approximation. Okay. Remember, the way that I set all this up was the width times like length 1 plus length 2 plus length 3, like all the way to the end, right? The constant for each of those is the width, right? Which is delta x. Okay, so the delta x for this from 0 to 3 with n integral, with n rectangles is 3 over n. So I don't want to put that in the summation because it doesn't change. that I can express as a Riemann sum. So, like what I was doing in my function, it was delta x times f of like that first, like that 3 over n plus f of 6 over n all the way down, right? So in my Riemann sum, I need f of something.
Is it gonna be the same?
It's not. So we need to notice a pattern. All of these are the original 3 over n times a number. Can we see that?
I did.
6 over n is 3 over n times 2. You keep going. 9 over n is 3 over n times 3. So there's my I, my index. Okay, so let's say 3 over n times I, where I goes from 1 to n, however many rectangles we have. Okay, questions on that notation? No? Everybody gets it?
Not really, but don't think about it.
Explain it again.
No, because you're just gonna explain it to me.
Okay, so let's do part E, maybe that'll help. Use 120 rectangles of equal width. No way would this question ever be on a calculator inactive portion, unless they were asking you to just set this Riemann sum up. Okay, so like this is our basic formula though, for a right endpoint method for this particular function. Okay, so using 120 rectangles, that's our n, right? Remember our n was the denominator of this. It was like how many rectangles we want. So in this case, we want 120. So like no way we can do that by hand. I mean, you could, but it would not be on a test. Okay, so let's use this formula, and all we have to plug in is n into our equation.
Let's go.
Three over 120 times the sum from 1 to 120 of f of 3 over 120 times I.
Okay, so I is always gonna, okay, in this example, I is always gonna equal 1. Like, okay, you know how over here it's times 1, then times 2, then times 3.
Mhm.
But on the top part, I equals 1. Like, I'm confused.
So that notation means the indexing factor. So what this notation means is 3 over 120 times, and then I'm gonna successfully like plug in i's from 1 to 120, like the integers, until we finish. So f of 3 over 120 times 1 plus f of 3 over 120 times 2.
And just keep going till 120.
Yep, and you just keep going
Okay.
all the way. to 120, which is f of 3, which is where we have to end, right? Okay, but if you're expected to find an answer for this, that's a calculator active question. So let's do that in the calculator. It's super easy.
Hey, when is the trip? Miss, when is the trip?
19th, let's see.
And how come Mr. Garcia's not going?
I don't have control of it, I'm sorry.
Yeah.
No, you don't need to see me.
Yes, it sucks, but It's
The
just,
art teacher?
we tried to fight it,
Yeah, he's a senior teacher, he's in the senior,
and he's on the senior team.
but he doesn't go to the trips because they don't let him. That's
They
messed
made a
up.
new rule, that you have to teach all seniors
All of them,
to go.
so Miss Cash can go?
Nope.
Ms. Knox can go?
That's, so Miss Wells can't go.
But they go on the,
Well, mostly seniors.
Miss Cash teaches.
Well, the only one who teaches all seniors is Fowler. He sees literally every senior.
Ms.
Exactly.
Wells does too,
Not everybody.
economics.
Oh, yeah, you're right, yeah, he teaches them too.
Then, so only them
So
two
it's
can
like
go?
most seniors. So that's why I'm allowed to go. Paquette.
How'd you get that thing?
But Garcia got like athletics and then like
I know,
art.
I'm not disagreeing with you, I'm just telling you why, their logic
That's a thug. And they just started this year?
this year, yeah.
Calculus, okay.
So, and we're going from I equals 1.
Does it have to be I, can we use another variable?
You can use that variable.
Yeah.
This is also why I entered the function in there, in my graph page, so that I can use it here again. Because I want to reference the function value. So if you can enter the whole function if you want like 2x squared plus 4x plus 1. But I would rather do f of 1. Okay, and then 3 over 120 times, in the function parenthesis, times I. Okay, so do you think this estimation will be better or worse than this estimation?
Better.
Better. Why?
It's more
Because it has more-
precise.
Why?
Rectangles.
Yes.
There's no place for mistakes on this.
Because there's an I in it.
Something in wrong.
It's not because there's not.
And there's no I.
More rectangles.
More rectangles, yeah.
Me too, that's it.
That is-
Oh, I'm missing something in my thing.
Ms.
Yeah,
Wells
the
took my
coefficient up
debit
front.
card away.
Thank you, Daisy.
Ms. Cash told Ms. Wells about the second debit card. She took it.
I'm gonna put it.
She took it from me?
Well, I didn't have it, I
Period.
left it in my jacket, but she never put it to me.
How does she know
There you
that?
Ms. Cash took it.
Where's the period?
How does she know?
I used it yesterday.
También
I used one in the other thing.
Okay, sorry, I forgot the 3 over 120 outside. There we go.
Why'd you use the one?
What was the actual integral that we calculated? 39. This is really good. So now you're seeing what we talked about at the beginning of this unit. More rectangles equals better approximation. Remember, if you're doing this, this needs to be rounded to 3 decimal places. 376. And they would probably grade this in a free response as like 3 different things. Like the correct width, setting up the Riemann sum, and the final answer.
So F is the same thing, just over 1,000 basically.
See that again?
The next one is the same thing.
Yep, but now using 1,000 rectangles
Okay.
of equal width. So what changes in my formula?
The 120.
Just the 120. Everything else stays the same. So is my estimation gonna get better or worse?
Better.
Even better. And we already have that in our calculator. So we can just go up and copy and paste. And change that 120 to 1,000. test the computing power of your calculator. Because when you start getting bigger numbers, it starts taking longer and longer to. Okay, so now we got 39.045. Really good approximation.
So,
Okay, and then the last one is 10,000.
do we put units at all?
Are there units in the problem?
I don't know.
No.
Oh,
No,
that's.
it's just a graph.
Okay.
So 10,000, 39.005. What do we do?
Why 10,000?
10,000, yeah.
But wasn't it about, oh.
That was the last
sorry.
The next one was. Okay, so now you can see the proof. More rectangles is better and better approximation. So maybe now you see where we're going with this? Limits.
No.
What if we have an infinite number of rectangles?
Did I not say that earlier? Infinity.
You did?
Yes.
Nice.
You ready for if you
So-
search this?
Here's our generalized formula for this infinite number of rectangles. So now, the definite of A to B of fx can equal that because we're finding the limit. We're not approximating it anymore.
I guess.
So the only difference with this is I actually wrote this differently.
I told you.
Sorry, I didn't even see.
I forgot it was.
Okay, we're gonna have to pick up there.
It's okay. That's
My bad.
And then same spot.
So much fun.